network is widely used in our daily life. There are some applications such as iPhone's Face ID. They use the image classification. This tool is key to send information without encryption. Because let's say using iPhone Face ID, your image may be sent to iPhone server, and iPhone server may get your image and do whatever they want. And also there are some mandatory protection of client's information. So it's necessary to protect client's privacy. A convolutional neural network is composed by linear layer and nonlinear layer. As you can see, the first one is linear layer, and the third one is nonlinear layer, and so on and so on. So for convolution layer is a linear layer and is used to get a filter of input image. And for point layer is a nonlinear layer, and by some research, convolution neural network spends the most of time in nonlinear layer. So our project focus on the improvement of nonlinear layer. And for the fully connected layer is a linear layer and is used to determine the final result. So our project objective is to implement nonlinear layer function in Gauss circuits, and we will use it to compare the running time to homomorphic encryption in nonlinear layer.
Let's talk about the problem setting. First, let's just take a look in this image, in these pictures, and we can see that imagine the situation that the clients have a query. Query means that there are some pictures. For example, if you need to send the pictures to the Apple server, then the query is your pictures, and your pictures should be encrypted, right? Because you don't want your pictures refilled to the servers, and your encrypted X sent to the server. Then the server will run his trained neural networks to compute the final result, and he will give the output to the clients. And the main point is that the clients doesn't know what the server's program runs, and the server doesn't know what is the client's input, and it can protect their both privacy. And the existing solution for this scenario is that for the nonlinear layers, they use Young-Scalabit circuit (GC) to do the encryption, and for linear layers, they use homomorphic encryption. And we just take a look for the homomorphic encryption. The homomorphic linear properties is on the addition and multiplication. This procedure or these properties is linear properties, right? And therefore, we can apply it to the linear layers. From Gazelle, which is from MIT, they have fully implement the neural networks by using the above solutions, which is Young-Scalabit circuit for nonlinear layers and homomorphic encryption for linear layers. And Mini-ONN do the same things to fully implement the CNN. And our current challenge is that the most of the time is wasted on nonlinear layer for the encryption. Therefore, if we can provide a much more faster encrypted method in NLL, which means the nonlinear layers, then we can improve the neural networks within encryption.
About API protocol. API protocol is used to implement Gauss circuits. So let's see the Gauss circuits interface. There are Gabler and evaluator in the Gauss circuit, and the Gabler will hold all key, but they only know the value of X, and evaluator they only know the values of Y. But the evaluator will get a suitable key by obvious transform, so that the Gabler will not know their input value. And let's say it's, for example, for a comparison circuit, and Gabler and evaluator will input their key to a comparison circuit, and you get the final result. And probably the Kabbalah will know which one is larger, but they still don't know each other's input value.
Let's talk about DGK protocol, which is a homomorphic encryption method. And the idea is on this formula, but we just take a look of the interface first. The scenario is that the clients host the value y and the servers host the value of x. The clients encrypt y by homomorphic encryption and send it to the server. After the server computations, then the server will return the value which one is greater by encrypted value, and the clients can decrypt this to get the result to determine which value is greater. And the logic of this computation is on this equation. This equation logic is that we do the comparison between the values bit by bit. For example, if we can, let's say there are binary numbers 101 blah blah, and the second value is 111 blah blah. If we can find the differences between this row and 0 and 1, then we can conclude which value is greater, right? In these situations, the second binary result is greater. Then we just take a look of this equation. S is the random key, either 1 or -1. We can ignore it. And for the xi minus yi, we just comparing the current digits, because there is a case that the former digits are all the same. Then what we can do to compare the values is to compare the current digits. And for the summation form, we just comparing the difference of former digits in, say, in these situations. And C is the output, which is Boolean, and then you can determine it by the true or false.
Let's talk about experimental setup. And we use 4 threads, and the CPU is Intel i7-7500U. And let's say for a number line, the binary form of line is 1001. Then its bit length is 4. So in our experiment, we use the input bit length 10, and the number of output is 12288. So we'll compare, let's say 12288 pairs of inputs, and let's focus on result. You can see all of function implemented by DGK protocol is faster than ABY protocol, about 885% to 1000%. And it's because for DGK protocol, it's low reliance on client's computation ability, because the client only need to encrypt the inputs and decrypt the result. And also for DGK protocol, it don't need to use OBS transfer. And the homomorphic encryption is performance is better than ABY protocol.
Our future directions. Our future directions is to fully implement the CNN, which means we have to implement the convolution layer and fully connected layer. And after fully implement the CNN, which we reconstruct the situations of Gazelle, we will record and compare the running time and accuracy of the implemented CNN by using ABY protocol and DGK protocol. And our used dataset is CIFAR10. And also, we will test with other dataset, which is minis for 10,000 testing number images and some text images dataset to guarantee our program or our machine learning code can be challenged by different datasets. We would like to express my sincere gratitude to my supervisor, Professor Sherman Chow, and the TA Lucian for his help, for their help and encouragement.
Thank you.